show you was how these, how these trig function values came about. In other words, I was trying to show you why sine of 30 degrees is a half, why cosine of 60 degrees is a half, that kind of thing. I mean, you don't have to memorize those values, of course, they're programmed into calculators. I did want to show you why these values hold. It's not like someone just out of nowhere said, I'm going to choose this to be true and this to be true, no questions asked. It's not like that. Math doesn't work like that. Generally, what you want to do is you want to prove something. You want to prove it's true. You want to show why this is true. And that's what I was trying to show you last time. I was basically trying to show you, remember, by considering certain specific triangles, you can actually show that these values are all true. Last time also, I presented the radian forms of 30 degrees. I presented these angles in radians as well. You can get that easily. You just convert from degrees to radians. Also, last time, I can get to it. So last time also, I did some examples with you, these kinds of examples where we don't know the angle, but we do know the trig function at the angle is a certain number. Like last time, for instance, we did sine of theta is a fifth. I think we also did secant of theta is something. So I did an example last time where sine of theta was a third. I think this example was a better one for me to do. So I'm going to do this one now. So basically here, with tangent of theta, right? I'm assuming theta is such that tangent of theta is a third. What we want to do is figure out all the other trig functions, but we're not going to figure out what theta is. What we do know is that theta is between 0 degrees and 90 degrees. And also, I did email you the notes. If you're not receiving the notes through email, please let me know. I did email these notes, so you should have them. So again, we want to figure out what the other trig functions are at theta. That's actually not that bad. What we want to do, remember, is we want to form a right triangle, one that has the angle theta in it, and with the sides labeled so that this is true. I know on this slide it says let them try, but I think it's better if I do this with you guys. Mostly because I didn't, mostly because I should have done this example last time. We want to have a right triangle where this is true. Tangent of theta is opposite over adjacent. So we want a right triangle. We have theta here, where the opposite side is 1 and the adjacent side is 3. Well, this kind of triangle, this kind of right triangle works, right? In other words, we want a right triangle where if I asked you to get tangent of theta, you're able to get 1 over 3. So we have a right triangle. I put theta down here. I label the opposite side as 1, and the adjacent side I labeled as 3. That's this kind of right triangle. So for this right triangle, we have this equation holding. Okay, that's good. Now, you don't know the hypotenuse though, right? Well, if we want to get the other trig functions, we're going to need the hypotenuse. You need all sides, all 3 sides, that is. Well, can we get the length of the hypotenuse? Well, yeah, of course we can, by Pythagoreans Theorem. So we have so we have 1 squared plus 3 squared is x squared. as you can see. I put the x on the left because that's the unknown. We have x squared equals 3 squared plus 1 squared. So x squared then equals 9 plus 1. Right? So again, we have x squared by Pythagoreans theorem. We have x squared is 3 squared plus 1 squared. So that means x squared is not equals 9 plus 1, which is 10. So x squared is 10. Well, that means x itself, we take square roots, we have to get square root of 10. So this third side has length radical 10. So now that we know the third side, we can get all the trig functions. Right? We know tangent already. That was given. Sine of theta, we know, is opposite over hypotenuse. Excuse me. So sine of theta then, right, that's equal to opposite over hypotenuse, 1 over radical 10. Like so. Now cosecant, remember, is 1 over sine, right? And what is 1 over this fraction? You just invert it. In other words, this becomes radical 10 over 1. You know, the denominator goes on, becomes the numerator, and the numerator becomes the denominator. So you turn the fraction upside down, so to say. And we get radical 10 over 1, which is just radical 10. Cosine of theta, right, that's adjacent over hypotenuse. So that's 3 over radical 10. 3 over radical 10. Secant is 1 over cosine. Right? So what does that tell us? That tells us secant is 1 over this fraction, which means you invert it. So it becomes this. That's good. All right. Now, so we know what tangent is. What about cotangent? Cotangent is 1 over tangent, right? 1 over tangent. So 1 over 1/3, again, you flip this, becomes 3 over 1, which is written as 3. So that example